As we have completed understanding the algorithm and writing the pseudocode of merge sorting algorithm, right? Let's try to write Python code for the same merge sorting algorithm. For that, inside this sorting folder, inside our project, I'm creating a new class called mergesort.py. Okay, here I'm defining a class merge sort. Okay, inside here I'm defining a function merge sort, and the first argument is always the current object's reference and an array or a list of values that we have been given. Here, as part of the first step, since we are trying to divide the array till we have only one value left in the array that we have been given, and we are trying to do it recursively, right? So as part of the first line of code, we have to write the base condition. So if length of a equal to 1, then we will simply return the array itself. Okay, if this is not the case, what we will do, we will try to divide the array into two halves. Two halves is nothing but from 0 till the middle index and from middle index till the last value. So how will we do that? First we will need to calculate the middle equal to length of a divided by 2. Now we need to call the same function recursively, right? That is nothing but self dot merge sort only from array containing values from 0 till the middle index. Okay, eventually this recursive call will end up having returning the arrays which are having only one values. Eventually whatever the parent recursive call, whatever it may, it will try to merge those two values, which we will be writing later on in this implementation, and it will return the sorted array. So that sorted array, let's try to store it in a variable called left. Okay, similarly we need to perform the same merging on the right side of the array as well. So we will call right equal to self dot merge sort, and this recursive function call will have values from middle till the very last, that is nothing but length of a. Okay, or else in Python you don't even have to pass this argument. If you just pass this syntax, right, it will take all the remaining values. Here I have put one extra parenthesis, so I'll simply be removing it. Now we have got the two sorted arrays. All we have to do is merge them. We have already written this merge two sorted arrays class, right? In that we have already implemented this merge two sorted arrays function. What we will do, we can simply copy and use that function here. Okay, and just copy paste. I have just copy pasted that function here. Okay, with proper indentation. Now I will call the same merge to arrays function. So what I will do, self dot merge to sorted arrays. For this I need to pass two sorted arrays, which are nothing but left comma right. Okay, it will return the merged array in the end. So we need to store it in the result array. Okay, in the end we need to return the result array which has been sorted. Okay, this is how we actually implement the merge sorting algorithm. For now, I will simply be going ahead and creating an object for this class, and I'll try to call this merge sort function so that I can validate the result. For that, let me create an object merge sort equal to merge sort. From this merge sort function, I need to call this merge sort function, and I want to call it with a array or list containing values 12, minus 10, minus 20, 1, 3, 99, minus 8. Okay, let's assume that these are the values I want to sort. In the end, it will sort and it will return the result, right? Let's say sorted underscore array. Now let's try to print it. Print sorted array. Okay, now let's try to execute it. Since it is inside the folder sorting, I will do python 3 sorting / merge sort.py. Okay, I'm getting an error. Slice indices must be integers or none. So it is saying basically indexes should be numbers. Middle is length. Okay, Yeah, length by 2 can give floating point numbers. Let's say if the length is 7, 7 by 2 will give 3.5. So it is not possible to slice the values like 3.5, 3.45, something like that. For that, we will simply import floor function from the math module. So import math. Okay, from this math package, let's try to use the floor functionality, that is math dot floor of length of a divided by 2. It will actually give us the valid indexes in which floating values have been cleared. So if I try to execute the same thing, okay, do you see the output? We've got -20, -10, -8, 1, 3, 12 and 99. Okay, that is how we actually implement the merge sorting algorithm. The thing that you have to remember here is basically merge sorting algorithm is a divide and conquer based sorting algorithm, and every time, even though the array that you have given has 1000 values, it will try to divide it into two halves till we reach a point where each and every half has only one value. Now, because each and every array that has only one value, it itself is sorted, right? Then it will try to work to merge those values, so that whatever the parent recursive calls that we have made, we will get the merged arrays, so that we can merge the left half as well as right half. In such fashion, we will get the sorted array in the end. Okay, that is something to remember when you are learning about merge sorting algorithm.